Hi everyone. So today I am going to discuss on the concept of sealed classes. Sealed classes which is available from JDK 15. So this particular concept exists in Kotlin and C Sharp. So I'll walk you through the particular concept of sealed classes in JDK 15. So before that, I'll walk you through an example of how the inheritance is working currently in Java and relate that particular aspect to the sale class. So currently, the example which I'm going to give for inheritance is using the dimensions. So we have the dimensions class. It has a method called dimension type which returns a string dimension type. So this is the base class. Now, ToDimension is another class which extends the base class dimensions. It is also having a method called dimension type which is overriding the method in the base class. So it returns 2D dimension. Next, we have another class called 3Dimension which extends 2 dimensions. So indirectly it is extending two classes. One is dimensions and the other one is 2Dimension. So we have the dimension class which has a method dimension type with a return type dimension type. 2Dimension which extends the base class, and 3Dimension which extends two classes which is dimension and 2Dimension. So this is how an inheritance is being implemented. So what happens? Let me just walk you through what happens when I run this particular classes. So this is the place we are going to call the dimensions. So if you're going to create an object of dimensions and call dimensions dot dimension type, like create an object of dimension class and call object dot dimension type, it's going to return this. So here what I've done is that I'm calling the 2Dimension. I'm creating an object of 2 dimensions and calling the method dimension type. Calling the 3Dimension class again, creating an object of 3Dimension, assigning into the base type, and then calling the associated method. So I'll run this particular class. So these two are the outputs. So let us walk through the output. So before that, I'll create one more class. Dimensions. Dimension. Okay. So this is the example. So here we have created class dimensions. Sorry, the object object of dimensions and calling its dimension type, which should return dimension type. So creating a direct object of dimensions and calling the dimension type method returns this one. The next is we're going to create another method, another object, two dimensions, and calling the dimension type. Two dimensions and calling its dimension type, which is going to return 2D dimension. The next is three dimension, and we're going to call, we are extending two dimensions. So we are going to create an object of three dimension which extends two dimension, and we're going to call the dimension type. So it is going to call the method dimension type from its parent, from its direct parent, which is two dimension. It's going to return 2D dimension as the output. So this is where the inheritance is working. So this particular base class method is being overridden here by its own implementation. Hence, that's why we are getting this particular output in this at this place when we are creating this two-dimension object. So here, even though two-dimension is extending or able to retrieve the method dimension type available in its parent, since it is getting overridden, it's able to return this value. Whereas in three dimension, it's able to get the value. This particular method, we don't have any specific implementation, whereas what we're doing is that we are actually extending its parent. So since it doesn't have its own implementation in three dimension, it is just making use of the inherited method from its direct parent, which is two dimension. Had two dimension, for example, assume we did not have this overridden implementation of two dimension. It will all inherit from the base parent, which is this class. So this is how the current inheritance in Java works. But there is a small limitation for this one. So what the limitation is, suppose there is another class like, okay. So currently three dimension is extending two dimensions, right? So just assume dimensions. This is the base class, so dimension string assume the parent is having this particular implementation. and I'm going to run this class. Yeah. So this parent class has the dimension value which is available in three dimensions. Because three dimension is extending two dimension, which is inheriting the dimensions. So what happens in this particular scenario is all the methods or instance variables or the instance or class variables available inside the dimensions are accessible in three dimensions, provided it is not overridden inside two dimension. If it is overridden, it's able to fetch the value from the two dimension. So the limitation is that possibly there are few places or few functionalities that might be useful or needed, that might be useful or that might be needed by three dimension from the dimensions, but it might not be necessary like all the methods should be available. For example, like in this particular scenario, possibly the developer would want to prevent, like developer would not want this method to be accessible to but only so the developer would want this particular method dimension value to be accessible inside two dimension, but doesn't want three dimension to have access to it. So that is a kind of a confusing scenario. So you want to have few functionalities available in certain classes, but not in some other classes. So this is the primary place where the sealed classes comes in picture. So the sealed class concept is being used in classes and interfaces. And what sealed class allows is it gives more control over the permitted subtypes. And the like if you want, so that is the like that is the use case of sealed class. So I'm going to explain you the use case or the scenario for the sealed class. So one thing which we want to ensure for the sealed classes, like I'll walk you through the classes which I've used for sealed class implementation. Is one is circle, fill triangle, rectangle, and shape. So we need to ensure that like these four classes exist in the same module with same project or within the same package. So now it's actually existing in the same module. Okay. So walking through the sealed class concept, we have the class called shape. Then we have another class called rectangle. We have another class called circle, and we have another class called filled rectangle. So what does shape have? So shape is a sealed class. So if you want to make a class as sealed, Java wants it to have a keyword sealed on front of it. The next is permits. So what does permit do? So permit is another, like sealed is a class keyword which denotes that shape class is sealed class, and permits is a keyword that binds the classes which can use the sealed class shape. So this is indirectly referring to the subclasses. So unless a specific subclass like circle, square, or rectangle has been mentioned explicitly with its parent class, it cannot inherit like any of the properties of the sealed class. So here, circle is capable of getting the features from shape. Rectangle is capable of getting the features of shape. And there is square as well, sorry. And square is also capable of getting the features from shape class. So yeah, so the permit is denoting like which all classes can extend this particular shape class. So currently the class shape has this particular method get shape. So this method can be used, can be received, or we can use this. We can get the method get. We can call the method get shape inside circle, square, and rectangle. Okay. Now walking through these three classes. The first is circle. So when it comes to circle, like circle is it extends the shape class, so it gets all the properties from shape class, but circle as such is a final class. So what happens is like whichever class calls a circle, it can instantiate this class, but it cannot override this particular circle class. So what is happening is circle can get all the methods from shape, but any class that is you consuming, or any class which is using the circle class, will not be able to override or misuse any of the methods of shape or circle class. So it gives a flexibility for the developer to design, okay, whether like only the circle class, no other class like that uses circle will be able to fetch the methods from shape class. The next is rectangle. So rectangle is another sealed class. So rectangle is a sealed class which extends the shape class, and since it's a sealed class, it should also give. So the key point to note here is like if we give a class as sealed, it has to be always combined with permits. The reason is because if a class is given as sealed, that means it has to be bound with some set of subclasses which actually permits to use this particular base class. Like for example, if I don't give this one, it doesn't throws an error because compiler actually seal class must always have subclasses. So seal class should be always be given a list of subclasses that it has to be associated with, because this is the place where compiler or JDK is able to map like this particular subclasses are attached to the seal class. So here fit rectangle is going to be the subclass for class rectangle. Now let us check fill rectangle. It's another final class which just extends rectangle, and square is a non-seal class which extends shape. So this is another keyword in Java, non-seal class, which denotes a class is not sealed or which is a kind of public class. So what is a non-sealed class? Non-sealed class can be extended by any unknown subclasses. Like we saw, for a sealed class, we need to give the permits, which denotes which subclasses need to be mapped or bound to. But when it comes to non-sealed class, it is kind of open class or a public class. So this particular class can be extended by any subclasses. We don't have to give any permits. And square is working like a public class, so it can be extended by any subclasses. So that is what the statement means. A sealed class cannot prevent its permitted subclasses from doing this. From doing this means from doing extending. Yeah. So that is the actual advantage. See, we need to have this is kind of similar to the 2-dimension, 3-dimension scenario. Here we wanted the functionality dimension value to to be retrieved inside 2-dimension but not retrieved inside 3-dimension. So what is how we are going to do with sealed classes? We have the shape class which permits circle, so that means indirectly it permits 2-dimension. But since 2-dimension or circle class is final, any like we cannot have the particular feature. We just prevent test shape from extending the circle, so the features are not available inside circle, like sorry test shape. So this is just a test scenario which I want to show. The next thing is I just want to run and show you the outputs. Okay. So let us walk through the outputs. So circle class. It will definitely be able to get the value from the it will be able to fetch the value from shape class. So it is able to get the get shape class. Next is rectangle. So the rectangle, it also extends shape class, so it's able to get the value using the get shape. The square, it's a non-seal class. It is also able to inherit from its parent. Now the filled rectangle. So this actually extends rectangle. It is also able to fetch the value from its parent get shape, because filled rectangle is actually extending rectangle and rectangle is actually part of the permits of shape. So it indirectly filled rectangle is able to get all the values from its parent shape class. Yeah, so this is the concept of sealed classes. I'll explore a bit more on this particular topic and will share our videos. Bye guys.